Good morning, students. Welcome to the class. In the previous class, we have completed Unit 6. Okay, up to Unit 6 we have completed. Today we will discuss Unit 7, which is 3D geometric and modeling transformation. Okay, first we know about what is transformation. Transformation are a fundamental part of the computer graphics. Okay, transformation are the movement of the objects in a Cartesian plane. Okay, so why we use transformation? Transformation are used to position objects, to shape object, to change viewing position, and even how something is viewed. Okay, for this purpose we use transformation. Okay, in simple words we can say that transformation is used for modeling and viewing. Okay, so the transformation concept also we have covered in 2D geometric transformation also. The transformation means same as in 2D and 3D, all of the same, but in 3D we add the Z coordinate, but in 2D transformation only two coordinates are there, one is X coordination and Y coordination, but in 3D there are three types of coordination: X coordination, Y coordination and Z coordination. Okay, so let us discuss in detail. "3D geometric and modeling transformation." Okay, when transformation takes place in a 3D plane, it is called 3D transformation. Okay, the geometric transformation play a vital role in generating images of three-dimensional objects with the help of this transformation. Okay, the location of object relative to others can be easily expressed in different terms. Okay, sometimes viewpoint changes rapidly or objects move in relation to each other. Okay, for this number of transformation can be carried out repeatedly. The methods for geometric transformation and object modeling in 3 dimensions are extended from 2-dimensional methods by including consideration for the Z coordinates, or in simple words we can say that the geometric transformation or different methods of geometric transformation can be extended from 2-dimensional to 3-dimensional, or 2D objects to 3D objects. And in the 3D object or in the 3D methods, 3-dimensional methods, we consider or include the Z coordinate. Okay, we now translate the object by specifying a 3-dimensional translation vector which determines how much the object is to be moved in each of the 3 coordinate direction. Okay, so similarly we scale an object in 3 coordinate scaling factors. Okay, in this figure, first figure is right-handed coordinate system. Okay, when we in the right hand coordinate system, this one is our y axis, this one is our z axis and this one is our x axis. That means the thumb is our x axis and the middle finger is our z axis and the second finger is our y axis. So in this way we can display the coordinate system. Okay, coordinate scaling. This one is your right handed. If the coordinate scaling factor is shown in the left hand system or coordinate system is shown in the left hand, In the left hand, the first thumb finger is your x-axis and the second finger is your y-axis and the middle finger is your z-axis. So in this way, the coordinate system, left-handed coordinate system represent this way. Okay. And the 3D transformation matrix is represented in 4x4 matrix. Okay, but in 2D we can represent the transformation matrix in 3x3 matrix, but in 3D transformation matrix it can represented in 4x4 matrices. Okay, let us discuss the types of geometric transformation. 3D geometric transformation can be divided into 5 types. First one is your translation, second one is your rotation, third one is your scaling, fourth one is your deflection, fifth one is your shear. Okay, all these things also we can cover in 2D transformation, but these methods are also follow in 3D geometric transformation. So let us discuss how translation can be occur or how translation can be performed in 3D geometry. Okay. Translation. Translation is the first method. Okay. It is the movement of an object from one position to another position. That means one location to another location. Okay. Translation is done using translation vector. There are 3 vectors in 3D instead of 2. In 2D there are 2 vectors, only x coordinate and y coordinate, or x direction and y direction. But in 3D it can 3 vectors. These vectors are x, y and z direction. Okay. Translation in the x direction is represented using tx, and translation is y direction is represented using ty, and the translation in the z direction is represented as tz. That means the distance, okay, from a source to destination. If P is a point having coordinate in 3 direction x, y, z is translated, and then after translation its coordinate will be p dash. Okay, that means the source point is the P and destination point is our P dash. Then if the source point P has x, y, z coordinates, then P dash has x dash, y dash and z dash coordinates. Okay, after translation. Similarly, in 2D matrix or 2D translation which used 3x3 matrix, but in 3D translation we use 4x4 matrix, that is x, y, z and h. Okay, so tx, ty, tz are translation vectors in x, y and z direction respectively. So according to this, x dash equals to x plus tx, y dash equals to y plus ty, z dash equals to z plus tz. Okay, so in this diagram, this one is your point P, which coordinate point is your x, y, z, and this one is your P dash. This blue lamp points is your P dash. That means this one is your source location and this one is your destination location, and the distance from source to destination is your translation vector t. Okay, so let's see the matrix equation. P dash equal to t into P. Okay, so P dash means x dash, y dash, z dash 1, equals to t into p. P is your x, y, z and 1, and translation vector is 1 0 0 tx, 0 1 0 ty, 0 0 1 tz, 0 0 0 1. So p dash equals to translation vector into p. Okay, so this matrix, all of you remember this. Okay, this one is important. All the matrix form, all of you remember it. So in this figure it will show you a object. Which one is this? One is your original location. This object is original location and the destination is your this one. So the object is moves from here to here. Okay, here to there. Next method is our scaling. Okay, scaling is used to change the size of the object. Translation is used to move the object from one location to another location, but scaling is used to change the size of an object. The size can be increased or size can be decreased from the original object. Okay, the size, when we can apply uniform as well as non-uniform scaling by selecting a proper scaling factor. Okay, scaling in 3D is similar to scaling in 2D. The method which we study in 2D same as scaling method in 3D. Okay, only one extra coordinate need to consider into it. The extra is z coordinate position. Okay, the scaling three factors are required: sx, sy and sz. Sx is the scaling factor in x direction, sy is the scaling factor in y direction, sz is the scaling factor in z direction. Okay, so in this figure, this one is your original object. This object can be increased. So this one is our resultant object and this one is our original object. After scaling, the object is look like this. Okay, now simple coordinate axis scaling can be performed as p dash equal to s dot p. Okay, so p dash means x dash, y dash, z dash 1, and p is your x, y, z 1, and s is your sx 0 0 0, 0 sy 0 0, 0 0 sz 0, 0 0 0 1. So this one is our matrix which we can remember it. Okay, now scaling in fixed point, we can enlarge the object but in the same location. Okay, fixed point scaling is used when we require scaling of object but particular point must be at its original location. Okay, fixed point scaling matrix can be obtained in 3-step procedure. First is translate the fixed point to the origin. Then first we translate this. Then scale the object relative to the coordinate origin using coordinate axis scaling. First we translate it, then we scale it, then again we translate the fixed point to back to its original position. Okay, so here first we translate, then scaling, then translate to the original position, back to the original. Okay, so let us see the equation. That means here p dash equal to t into xf, yf, zf T means translation into S into Sx, Sy, Sz, S means scaling, okay, into T into minus Xf, minus Yf, minus Zf, that means minus Y, that means back to the original position, okay. So that's why we use minus, okay, into P is your what, XYZ original position, that's why the first translate it, then scaling it, then translating to the back position, back to the original position, okay. So after that the P dash matrix is this one. This one is your if only formula form and this one is your matrix form. After multiply these three matrix, after multiplying these three matrix, we can find out this matrix. That means we only remember this matrix formula and this one is your for reference. After that we write this formula in a matrix form and multiplying it, the matrix multiplication, after that we can get this matrix form, okay. So P dash equals to Sx 0 0 1 minus Sx Xf 0 Sy 0 1 minus Sy Sf 0 0 Sz 1 minus Sz Zf 0 0 0 1 into P. So this one is our final matrix form, okay. So this matrix form is our in fixed point scaling, okay. So all of you remember this. So translation and scaling, these two method we will cover in this class. In the next class we will next method we will read, okay.